Solve another problem from the electrostatics of TIFR 2025 question paper. So the problem states that a very long square pipe with length L and cross-section area A square, L is much greater than A, has an ideal conducting wall. A traveling mode with Ez equal to Ez equal to R is the function of R and T, A sine pi x by A into sine pi y by A into e to the power I kx minus I omega t is excited in the pipe. So what is the relationship between K and omega? Assume epsilon equal to epsilon 0 and mu equal to mu 0 means is the permittivity of the free space and magnetic permeability of the free space. Okay. So so we have given it is given that E z as a function of R and T is equal to A sine pi x by A into sine pi y by A into e to the power I k z minus I omega t, right? In a perfectly conducting square waveguide. So in a perfectly conducting square waveguide, right? So waveguide modes, the field satisfy the Helmholtz equation, right? In waveguides, the field satisfy in waveguide the fields satisfy the Helmholtz MHOTZ Helmholtz equation, which states that del square Ez plus omega square c square Ez equal to 0. Let's compute del square Ez. Since the dependency is Ez is dependent on psi pi x by A into sine pi y by A e to the power I kx z, sorry, here it is kz. The Laplacian gives, we have the Laplacian form is del square x by del x square plus del square by del y square plus square by del z square. We can write this del square as this. So each term separately we can integrate, means we can integrate del square by del x square into sine pi x by A equal to minus pi by A whole square into sine pi x by A. Similarly for x, similarly for y, we can write del square del y into sine pi y by a. So we can write that pi by a whole square into sine pi y by a, right? And for z we can write del del z square e to the power I k z, which will be minus z square e to the power I k z. Right, so the total we can write. So in total we can write. So the total we can write del square is z equal to minus pi by a whole square plus pi by a whole square plus k square into z equal to minus 2 pi square a square plus k square into ez. The Helmholtz equation is the Helmholtz equation. The Helmholtz equation is minus 2 pi square a square plus k square ez plus omega square c square ez equal to 0, implies that a square equal to omega square by c square minus 2 pi square by a square. Taking the square roots, we can write that a equal to root over omega square c square minus 2 pi square a square pi square, right? So, so this is the option which we have in our question is option number A. So option A of the given problem is the correct answer of the problem, right? So hope this problem as well as the solution is clear. So thank you for now.